So in platform technology, what we have discussed so far is we have talked about basic computing, we have talked about networking, we have also talked about how these things can be organized in certain structures. And then one of the things that is going to happen is when we are having these computers interconnected and different computers communicating with each other, we are going to have this setup of clients and servers. So there are some computers that are going to be clients, and there are some other computers that are going to be servers. So when we talk about that, there is a possibility of organizing these clients and servers in certain different architectures, certain different organizations. So that is what we are going to be discussing today. We are going to look at some different types of architectures in which clients and servers can be organized. So this is again one of the things that we can focus on when we are building larger platforms, when we are building larger enterprise level computer systems. We can think about these different client server architectures, and then we can see what would be the most suited type of architecture for a particular application. So first, if we think about the basics of clients and servers, essentially they are still going to be, in terms of their computing, they are still computing devices that are connected to networks. So they will be somehow connected to networks. So they can be connected through, say, a local area network, or it could even be a wide area network like the internet. So the main thing is the clients are computers, the servers are computers, and then there is some form of connectivity between them. So the main sort of differentiation that we will see here is the programs that are running on these computers. So the server will be the program, or it will be the one that is servicing. It is going to provide some service to other computers. So it is going to provide something. Whereas the clients are the ones that are going to receive that thing, receive the service from the server. So the programs on the clients will be mainly about receiving the service from the server, and the programs on the server side will be mainly about providing this service to the clients. So if we think about web, for example, a web server and a web browser, so those are the two ends. The web server is the application that is running on the server, which is going to provide the websites, web pages to the client. And on the client side, we are going to have a web browser that is going to access information from the web server. So that is the both sides of this clients and servers. So if we look at an example, another example that you may be familiar with, which is the ATM network of a bank. So if we think of a very simple architecture for that, what we will have is each of the ATM machines are individual devices, individual computing devices that are able to do certain functionality for the end user. But then to know how much balance is there in a person's account and so on, there should be a server. So there should be a centralized server from where the bank server, from where the ATM can know how much money you have in your account. Then only it can make a decision how much money it can pay you, say if you are withdrawing some money. So then that server will be on the bank side and the ATMs will be on the client side. So these are again an example of how this client server model can be set up, a basic way of setting up this client server model. So when we think about such client server models, we can think about certain requirements that we may have, certain requirements that we need to have for us to establish this type of computing. So for example, if we are only doing all our computing in a single computer, so everything is happening in the single computer and the user is also directly connected to that computer, then the requirements are fairly different. But when we think about a client-server model, one of the main requirements that we are going to need is a robust and reliable communication network. So this client and the server needs to be connected, and that connectivity should be always available or available when needed. So in the case of an ATM network, the ATM should be connected to the bank server all the time. So if that connectivity is lost, people will not be able to take out money from the ATM. Then the other thing is the client and the server should be able to work in ways that both of them can understand. Say for example, in the case of a web server, if you're accessing a website, your web browser should send a request in a way that is understandable by the web server, and the web server should respond in a way that is understandable to the web browser. So there should be some level of cooperation between these two parties, the client and the server. So when a client is requesting, it should ask in a format that is understandable to the server, and when the server is responding, it should respond in a manner that is understandable to the client. Then in many ways, the server will be in control of many things. The server will be in control of the data. The server will be in control of the main services that it is providing. So in the case of a bank server regarding ATM network, the bank server will hold the information that is necessary to the ATM server. Bank server will have the centralized account balances which is needed for the ATM server. And then also, if there are conflicting requests, then that also needs to be handled by the server. Again, if we think about an ATM example, if somebody is taking money out of your ATM account, by your ATM card, and you are also at the bank trying to withdraw money from the bank teller, now if these two things are trying to happen around the same time, then the bank server should be able to figure out that and effectively manage. So which is the transaction that is going first and which is the transaction that should be denied or that should be modified accordingly. And one of the other things that we would notice with this type of client-server model is it would be more like we will have more sort of centralized server and many clients connecting to it. Again, in the case of an ATM server, there will be one bank server, but many ATMs will be connecting to that. Or in this case of a web server, there will be a single web server, but all the different users can access the same web server. So that is also we would observe in this type of a setup. In a client-server architecture model, we will observe that. Then when we think about client-server architectures, there are a number of different ways these client-server computers can be arranged. So what we are having is we have a client and we have a server. So between this client and server, so rather we will have many clients and maybe one server or maybe even two servers. So then we have to know what is the way the relationship between these things can be organized, how these things can be set up in an architecture. So that is what we are going to be mainly focusing on today. So there are a few different arrangements that are possible, and we will discuss some of these in a bit more detail now. So one of the most simplest setup that we can have is what is called a two-tier architecture. So in the two-tier architecture, what we have is we have a client and we have a server, and between the client and server, we will separate certain functionalities between the client and server. Some things will happen in the client end and some other things will happen in the server end. So again, we can differentiate between how specific things are organized in which part, but the main idea is only two parts are there. One is the client and the other is the server, and some functionalities are split between them. And one of the other possibilities here is we can sometimes split certain functions or certain operations between the two ends. So what we can have is we can have certain aspects inbuilt in the client. So for example, we can build the business logic and the presentation logic in the client side. So presentation logic is the end results being displayed to the user. Business logic is the logical operations that we will do with the data, and then database logic is accessing the database. So some of these parts we can build on the client side, and some other parts or some parts of database logic we can build on the server side along with the database system. So we can organize these things in these different aspects. And then when we think about clients specifically, we can have what is called fat clients and thin clients. When we say fat clients, what we have here is we have clients that are able to provide much more functionality. On the other hand, when we say thin clients, we are talking about clients that are only performing limited functions. So depending on the application, depending on the type of thing that we are building, we may sometimes build them as thin clients, so the not much implementations are there on the client side, but sometimes we may build them as fat clients, so most of the things are implemented on the client side. But one of the problems that we may face with building these type of two-tier architectures is we are going to be relying on only one type of possibility. We are going to have only one type of a database, because we cannot have, so the backend is going to be fairly fixed because there is only one possibility there. But one of the more important issue is we are going to be limited by the things that can be done by the backends, because only one server entity is there. So every request needs to go to that particular single server entity. So then that is also a limiting factor, because we only have one client side and one server side. So any communication between these two things will be limited by what is possible by this client, by this server. So all the requests, all the clients are going to be relying on them being served by the same server. So then that could also be an issue. So then it can create issues related to, say, scalability. So we can scale up, we cannot scale up our applications to much larger environment. So again, if we grow to more and more number of users, again we need to have we need to support more and more loads at the server side. So then we need to build much more powerful servers when we have that. So then that is also an issue that we may encounter there. So an alternative way of building a client-server model is what is called a three-tier architecture. So this is another architecture that we can have, that is the three-tier architecture. So what we are doing here is we are splitting the server-side functionalities into two parts. So instead of having a single server that is doing everything, we are splitting the server-side functionality in two parts. And one of those parts is going to be responsible for what is called the application server. So they are going to handle the applications, business logic. So all the program related things are going to be done at the application servers, that layer. And then all the database aspects can be done at the backend layer or the database layer. So we can split them into three tiers. One is the client. The clients are going to be the same, but then the clients will access the business logic or the applications on a server. So that will be the first access that the clients will do. So any number of clients will connect to this server or that first part of the tier, and then any access after that will only be between these servers. So the backend server and the middle layer server will be communicating between each other for data access reasons. So the databases and so on will be set up like that. So the main aspect about the three-tier architecture is we will have the first part of the clients. So clients will be accessing these services, and from the client's point of view, they are only connecting to the middle layer, the first tier, the second tier of the architecture. So these servers are the ones that the clients are going to access. So in the case, say for example, if you think about a web server, this is the one that is going to be the initial web server that you are accessing. But on the back end, the web server may use additional data servers like a database server and so on, can be separate servers that it is going to access when needed. So all the users will be connecting to this first tier, the second tier, the middle layer, and then the backend layer will be used by the middle layer itself. So this is only used by the services. So that is the basic three-tier architecture. So there are a number of reasons why we may want to use the three-tier architecture, and it has a number of benefits, particularly comparing to the two-tier architecture. So one of the main things that we are doing is we are splitting the application layer or the application logic from the data part. So we have the application logic in one server and the data part in another server. So when we do that, we can have more robust applications because those servers are only doing one thing. So we can build them to cater to that particular functionality much better. So the initial application server, we can build it to handle more requests that are coming from outside world, from clients, and we can build the backend server to handle more data processing and that type of thing because that is at the backend server. So we can split it like that. And one of the other possibilities is because now we have split these things into two parts, the middle application layer, middle program layer, the logic layer, now can access multiple databases. Because in the two-tier architecture, we only had to use one type of database of only one data source because that is built into the same server. But here now we are splitting that aspect separately. Now what we can have is we can have one main service layer, and that can access different databases. So it can have multiple databases that it needs to access. So the client will connect to the server will access multiple data sources as it needed. So, and at the same time we can build multiple backend servers or multiples of these servers, so that can also improve our performance, improve reliability and so on. So there are some additional advantages we can get by using this type of a three-tier architecture. But one of the main drawbacks of using three-tier architecture would be because it is going to be much more complex. Now we have to have much better ways of managing the network communication, the integrity of data. So there's going to be much more effort needed to establish this type of a server and maintain and continue to use this type of a server. And there we will still have some level of dependency on relying on. So this is not totally going to eliminate us from having these servers or these type of setups. So we will still rely on these type of platforms, certain application servers and so on. But we can still separate things into independent units. So then we can have a much better environment than this two-tier approach, but it is going to be more complex to set up and maintain. So if we think about some actual real-world examples of three-tier architectures, the actual ATM network, when we were previously discussing about ATM networks, we sort of briefly said there will be an ATM and a bank server that it is going to connect to. But in an actual ATM server, it would more likely be even more sort of a complex structure with, say, the ATM machines being the clients, and then there will be a middle tier servers that will provide certain banking functionality. So they are going to do the checking balances and all these functionalities will be there. But then there will be backend servers that are going to actually maintain the data. So they will do concurrency control, the transaction processing, and those things will be done at the backend. So ATMs will connect to an ATM management server, and that will connect to the backend server. Similarly, if you are taking money out of the bank, that bank teller server may connect to a teller computer, may connect to a teller server, and that will also connect to the same backend server. So the same database or the same data backend can be accessed from two types of applications. So these are some of the ways that we will set up three-tier architectures. Same thing is true with sort of modern web applications. So we will have the web browser as the client, and in many sort of web applications these days, what we have is we have some additional programs that are actually running inside the web browser itself, like JavaScripts and so on, may run like that. Or sometimes we may have some application servers somewhere else that are doing some of those things. Then we can have additional backend databases and so on supporting the as sort of the backend server. So we can have more logically separated structures, architectures in more real world applications. So then we can also briefly talk about another variation of how we can split these things, and particularly when we are talking about two-tier architecture, we talked about how different things can be split between the client side and the server side. So when we talk about that, if we take most of the logics back to the server side, if we take most of the logic, business logic back to the server side, then what we will have is a fat server. Most of the logics are built in the server side, so that becomes a fat server. But on the other hand, if we build most of the logics on the client side, then we will have the fat client. So we can have either a fat client or a thin client, or a fat server or a thin server. So this will depend on how much we are implementing. So if these are the total things that we have to implement, we can split that between the client and server in different organizations. We can only have limited number of things on the client side. Only the presentation layer is on the client side. Everything else is on the server side. Or everything else is on the client side. Only the database is on the server side. So we can build it in sort of different ways between the client and the server side. So one of the main advantages with fat servers is, and also a good example of building this type of fat server applications is when you think about web applications particularly. Most of the time you are only using a client, a web browser as a client, and not much logic is happening on the client side. Maybe there are some JavaScript codes are running on the that type of dynamic content is being displayed on the client side. But other than that, most of the business logic is happening on the server side. So that type of fat server has a number of advantages. So the main one is there's no need to update the application. So no need for the clients to update the application. So if you think about Gmail, for example, a web email service, for example, you don't do any updates to the Gmail service. All the updates are done on the server side. You are just visiting the website every day. If there's a new update, that will be there for you, because your client doesn't have much logic on its side. Everything is on the server side. So there's no need. The clients don't need to get involved in the update process. So any other web application, same thing. Say for example LMS, same thing. You don't have to update the LMS on your side. You can just go to the LMS application and use the functionality. If the LMS is updated, again, you will get to use that without doing anything from your side. And the most of the data is going to be on the server side, so it can be much better managed than how it can be managed when it is on the client side. So most of the data will be managed on the back end, and everything will be processed there, and only the results will be provided to the client side. So it will be much more easily manageable because it is centrally there, so it can be easily managed, and also because all the processing is done, only the results are being sent, so not a lot of data also needs to be sent back and forth between the client and server. So it will be much more easier if we are building this on the server side. It will be much more easier for us to maintain that much effectively, because it is in more control to us than trying to manage a client-side device. So even in an organizational environment, the server can be put in an environment that is more effectively manageable than a client-side computing device. So that way we can have much more simpler clients, and every complexity will be built on the server side. So that is the advantages of having a fat server. But there are certain advantages are there on fat clients as well. Fat servers have a lot of advantages, but there may be certain situations where you may want to do fat clients. So that is building most of the functionality on the client side. So the reason is one is like the client side changes doesn't affect the server. So for example, if different people are going to use different types of clients but with the same data source, then most of the logic can be built in the client side, and they are just accessing the same data source from the server side. So the server side is not having a lot of logic. Each user or each application is having its own logic built separately on the client side. And other one is there can be more sort of features implemented on the client side, because it can use more specific features particular to that client type device. Say for example, if you are using it on a mobile device, if you are using it on a computing device, on a tablet device, on a handheld or an embedded device. So different types of devices, you can build different types of clients more suited for that type of an application, and everything accessing the server side in a only for that data access part. So there may be some situations where we may want to build fat clients, that is building most of the functionality on the client side. So one of those variations is what we can call, another sort of variation of this architecture is what we can call as an architecture called locating the data. So here what we are doing is we are going to have multiple data servers. So the client is going to build most of the logic here. The only part it is going to do is accessing the data, and the data access part also can be built as multiple databases. So that is the main difference here. We are building data access on the server side, and we can do multiple databases, multiple variations of databases. So this can be for backup purposes and so on. We can build like that. But we have to think about data integrity, how data is synchronized between different servers and so on. We have to face some issues like including more complex administration needs and so on will have to be addressed there. But the main thing is we are splitting the data only to the server side, and we can also have additional data sources at that end. So when we are talking about this type of access between clients and servers, particularly with multiple data sources, multiple data access points, one of the things that we have to think about is this transaction processing. And one of the things that we would want to have is what is called this ACID properties. So if we think about the example of banking example, say you are going to take money out of the bank at the bank teller. So you are going at the counter at the cashier and you are asking to withdraw some money. At the same time, you have given your ATM card to a friend with the PIN number, and they are going to try to withdraw the money from the ATM. So now if you can manage to put these two requests at the same time, are they going to give the money to both parties? And it should not happen that way. So there should be atomic transaction processing happening. The transaction processing for these two transactions should be managed in a more effective manner. So that is what we call, or what we identify with this ACID properties. So that is, atomicity is only one of those transactions should be completed first before going to the next one. Consistency, we expect the same type of results every time if the transaction is repeated. Isolation is the transaction should be separate from one another, and durability is the results are staying for a long period of time. The results are permanent. So we would expect that type of operation when we are talking about transaction processing. So to do that, we will have certain type of transaction processing management, or TPM, in our servers, and we will have to build that when we are building these type of larger platform environments. So this particular area is sort of beyond the scope of what we are discussing today in more detail, but just remember that these are some of the additional things that we will have to build when we are building this type of multi-tier architecture, client-server models, client-server architectures. So then another variation we can have in this type of architecture is what is called the NT architecture, or multi-tier architecture. So what we have here is we are again splitting the layers, but it's now just not 3-layer or 2-layer, now many layers. So we are splitting them into many different layers based on our applications and so on. So for example, we can have a web access layer first, then a web tier. We can have multiple middle tiers doing different things. We can have a cache layer, and then we can have remote services, data tier, and so on. So we can have multiple layers doing multiple things. So So this will depend on what we are actually building, the service that we are building. We can split that depending on what are the different applications that need to run. Say for example, we need to check authentication of users and then we can let in to the server. That can be one thing. The web application is one thing. Then there can be a middle application that it is running, checking with. That can be one thing. Then there's another data layer, that can be one thing. And all these things can be split into different servers. So, and this will be necessary when you are building larger platforms. Say if you are only doing a single server for a small number of users, having 2-tier or 3-tier architectures would be sufficient. If it is a very small thing, 2-tier may be okay. If it is somewhat of a larger one, maybe you go for a 3-tier architecture. But if you think about a larger environment, like say Google or a Facebook, that type of a larger online based service, for example, they may have to cater to larger number of requests and different types of requests and so on. So then they will split that into multiple logical layers and they can be put into different physical tiers, different computers, different servers, and they can run independently like that. So that is what we identify as a N-tier architecture. So with N-tier architecture, what we would have is what is called asynchronous connectivity. So different things can connect to different aspects, different logical layers and so on differently. Data can be distributed using replication. So we can have multiple copies of data and it can be accessed by different parts. So again, if you think about a larger web application, it may not be practical for only one server to cater to all the requests. So then there will be replicated copies of the same data and then that can be served to different users. Then there will be additional services, more complex data types. They can do more complex analysis in the backend, like big data analysis and so on, relevant to artificial intelligence, machine learning, all these things. We can build them in the backend. We can build authentication services separately. So your login services are done separately. The main logics are done separately. So we can separate them. We can have different file systems separately. So on, like we can separate any number of services into different layers and we can have these multiple tiers to support these different layers. So an example that we can see, say if we are thinking about a web application, for example, we may even do this in multiple virtual machines. So the requests are going to come from the internet. Then we have a load balancer service that is going to send requests to different servers. So then that can go to different parts of the different servers. Then we can have additional load balancers at each layer. So then whenever requests are coming, then they can go to different computers or different servers. So then each of the layer can serve multiple requests using multiple servers, for example. So we can have different entities like that working together in different physical layers and different physical tiers and different logical layers. So that is what we do with N-tier architectures. So this is particularly useful when we are building significantly larger applications, larger web applications, larger interconnected applications. This would be very much necessary. So a simple web application would run even on a single computer, but if we think about larger number of users, millions of people accessing, then we may have to build it like this. Then another type of client-server architecture is what we call as microservices architecture. So microservices are somewhat different. And what we have here is what we would have is a client would try to access these services through an API gateway. And then inside that, what we have is different services. So what we mean by different services is these are different type of functionalities they can use to do different things. So there can be different services. One is providing information, another one is providing some other type of information. So different services can be there, and the client can connect to any number of these things and access that information. A good example for that could be, so if you think about in a smartphone, it may connect to different data sources and collect some information and display it on your home page, or displaying it as notifications like weather information, latest news, and so on. So it is going to access those things. So there it is not accessing them as a website, it is accessing it as a service and getting that information through an API gateway, through an API. So what it needs to do is it needs to access the weather API to get the weather information. So that would be one service. Then it would access a news API to get some news updates or news headlines. That would be another service. So there will be a number of these services, and different parties may build these services. So again, if you think about weather services on mobile phones, you may see these weather services can be provided by different service providers like an AccuWeather or weather.com, or different service providers may provide that service. So you may choose a particular service and that service may be used. So that is the microservices architecture that we can have. So we access this information or access these services using APIs or application programmable interfaces, and most of the time there will be additional clients and applications that will be using the information that is coming out of these services. So there are a number of advantages that we can have with this type of microservices architecture. We can build much more smaller focused applications. We can change them much more easily. So we have agility. So only a weather service is only about the weather service. So if there are any changes needed, we can only update that. And the backend is always accessed by an API, an application programmable interface. So as long as the interface is accessible, the backend can use, the services can be built using any type of technologies. And if there are any issues, any faults in the service, again we can isolate them because they are built separately. And when we are building to large number of users, large number of services, then again it will be much more scalable as well. So there are a number of advantages why we want to use microservices. But on the other hand, it will add some level of complexity. There is a need for a better management because many people can build these type of services. Then there's lack of control in what is happening. So if you are if you can select between different weather services for your mobile phone, you may not know which weather service is going to provide the accurate information. Some may be good, some may be bad. So there may be that type of issues can be there. And one of the main issues is this is going to be largely dependent on the network connectivity because the services will be provided through the network connectivity. Another type of architecture that we can have in client-server models is what is called a web queue worker architecture. So what we have here is, and this would be used in a particular type of a scenario, that is, the request from client will be coming from a web interface, but once the request is performed, then there will be much resource intensive things need to happen on the server side. For example, if you request a backup from a website, so you are asking to download all the files on the website to your computer as a whole. So it needs to put all the files into an archive and provide you that information. Or if you are going to go through all your financial statements and produce a statement file as a PDF. So then the access request is very simple. You go and click a button and say produce backup. So from the web end, from the web front end, the request is very simple. But on the back end, the request is very complex because it has to consider all the data points and produce these things. So what we can separate is, so these are back end intensive operations, but from the front end, nothing much needs to happen. So we will separate the web front end for the client requests, and when the requests come, we will put them into a queue. So we will manage these things into a queue, and then we will use a worker layer to go through the queue one by one and produce the output. So for example, if say 10 users are going to request the backup data, it will put all the 10 backup requests one after the other in the queue, and then the worker layer can go and produce these backup one after the other, and then the users will be updated when these things are ready. So there will be what is called message passing between this front and back ends. They will update saying this is complete. So you may come across this even, say, if you actually go into Facebook, for example, and request all the data backup from Facebook. If you go to settings and request all data backup, what they will say is you will be informed when the backup is ready. You only need to click one button, say request backup. Then they will go and produce this backup in the backend, and then they will provide you at a later date when it is ready. So that is the web queue worker architecture. We will mainly use it when we are using this with resource intensive, long running. So these processes take time to run, things that are running in the back end. So the main advantage is we can separate these complex functionalities from the front end, and the back end can do those things. So the front end user doesn't have to wait until that is complete. So you don't have to click the backup and wait until that is produced. You can just send the request, and then that will be processed in the back end, and then you will be informed when that is ready. So that asynchronous ability. And also we can separate, because we are separating the front end and the worker layer, both of those things can be scaled up. Say we can scale up the front end to handle more requests, and maybe if we want the back end also to function fast, maybe we add more worker computers or worker servers, processors there. So we can improve that side as well, and we can do them independently. But the problem with this approach is we have to carefully plan and build these things. Otherwise, we may build more things on one end or more things on the other end. And also we may not know, there are these things have to be, because the front end depends on the back end and the worker. And so any updates happening in one end should also consider the changes needed on the other end. So there are some of the challenges we will have in web queue worker, but regardless it will be mainly useful when we are considering these larger data processing situations that needs to happen in the back end. Then another architecture that we may think about is what is called the big data architecture. So this is another thing that will be common in sort of recent application, recent sort of way of computing with cloud computing and so on. We are having a lot of data stores. Data could be stored in these larger data applications. So what we can have is we can again have the data sources separately, and then we can do the analytics part separately. So when we are doing big data analysis, data can be collected and put into these data stores. And then we can do various batch processing, analytics and so on can be done separately at separate times. So we again split both of these things can be in the back end, but we can split them into these different layers, and those different layers can be considered at different servers and clients. So this is particularly useful when say in a typical database server, in a typical database system, we do all the analytics and everything in the same service or same server, for example. But here what we can do is the actual data will be stored on one server, but the application processing analytics will be done on another server, and we can split them into again multiple layers based on the logical organization there. So that is big data architecture. And another option that we have, again similar in the sort of cloud computing era, is what is called the big computing architecture. So here what we have is we will have the clients that are having request the jobs to be performed, and that can be sent to a scheduler, and then we will have multiple instances of computing. So multiple instances where it can do computing, and these tasks can be sent to these separate computing instances for it to be processed. So again, when we think about larger processing needs, like when we need sort of larger visual effects, if you are thinking about larger financial data analytics, or even certain engineering analytics type of applications, we may do these type of larger computing requirements. So we can separate the client from the actual computing part, actual processing part, and the processing can happen in the server side, and the client can just create the request and forward it to the server, the processing through a scheduler. So that is big computing architecture, the big compute architecture. So this is again another way that we can use larger computing infrastructures that are available through cloud computing, for example. Then another concept that you may come across when we are talking about these client-server architectures is what is called a middleware. So again, we are not going to go into this in much detail, but the main thing to understand is middleware is basically a way to, it is almost like a virtualization, just to understand conceptually, but it is not the same thing. But middleware is basically a layer of services, functionalities that is going to provide, that is going to service any applications that are using. Then we can have different operating system platforms at the bottom layer. So we have a middleware layer that is going to connect all these different things into a common architecture, and then all the other requests can be catered through the common architecture. So normally it will build a number of application programmable interfaces, and applications can connect using these APIs, and then it will build this middleware to be able to connect to different underlying systems there. So that is the middleware. We separate the underlying computing infrastructure from the above application infrastructure. So this is also somewhat relevant in the client-server architectures we talked about. So finally, when we talked about client-server architectures, we talked about a number of architectures, a number of different ways we can organize: 2-tier, 3-tier, N-tier, then even the sort of different architectures. But one of the common things that we will come across with all these approaches is so some issues is related to networking, network connectivity, and the ability for our connectivity to be scaled up. So if many users are connecting, how we can scale up, and so on. Then when we are having data at the backend, and if we are replicating, distributing data across multiple servers, again, how we are managing that. Then processing, when processing is distributed across multiple servers, again, how that is going to be managed. Then when we split these things into multiple servers, now we have to manage these different systems independently and but also collectively. So how we are going to maintain and manage these sort of complex system structures. Then we will have to have some level of middleware so that we are able to connect to these things in a much more effective manner. And one of the ways that we will go about doing this is having standards. So there will be certain standards these things have to talk to each other. So if we talk about web servers and web clients, there is a way of talking between a web server and a web client. So there is a standard. There will be some open systems, open standards that are implemented for most type of services. So they can be talking with each other without having to build more specific functionalities in those situations. So these are some of the things that we will encounter when we are talking about client-server architectures. But regardless of that, we will have a number of advantages with using these type of client-server architectures, because we can separate these functionalities logically, and then we can put them into different physical tiers or different servers, for example, and then we can maintain and manage them independently. So we can update them independently and so on. So there are a number of advantages like that, particularly when we are thinking about larger platforms, larger systems that are catering to larger number of requests. It would be impossible to put all of them into a single machine. So splitting them into multiple machines with multiple sort of logical layers based on functionality would have a number of advantages to scale up and cater to larger number of users. Then in terms of disadvantages, once we go with the client-server approach, then we will always encounter this problem of a bottleneck of how much request a server can cater. So we can keep on increasing the number of requests it can cater, we can build redundancies and so on, but it still is going to be an issue. If the server is not there, then the client will not be able to access that. So it is going to be much more complex to build, and so the advantages are there, but there are some disadvantages also we need to consider. Particularly this is important so that you don't build this type of an approach when it is unnecessary. So only when the advantages are useful, we will go for this type of an approach. If the advantages are not needed for us, then there's no point in working with these type of other disadvantages that may be there. So we can think about those as well. So that's largely what we had to cover when talking about client-server architectures. The main things that you will, other than the architectures, those architectures that we discussed, also thinking about identifying what we can think as a client, what we can think as a server, and particularly with sort of current way of computing, also thinking about APIs and middleware would also be important for you. So those are essentially the number of topics that I wanted to cover in today's lesson. So that is basic about client-server architectures. So are there any questions on things that we discussed today? If there are no questions, we may conclude for the day. And as mentioned previously, we will have another lesson to discuss about system administration, some basics about system administration. And after that, we will think about how we can do the practicals. And additionally, I have shared some additional resources on LMS to some free online courses that would be really useful for you to gain some knowledge and also some practice on various things. So have a look at those and take advantage of those as well. So other than that, that's all for today. Thank you for joining in this lesson. See you next time. Bye.
Thank you, sir.